Good day, class. Welcome to our video lesson for our physics subject. And in this lesson, we will discuss the law of magnetic poles. So to do this, let us have a quick journey back in time to understand how these laws came to be. Bakit ba tayo nagkaroon ng law of magnetic poles? So in 1269, a French scholar named Pierre de Maricourt studied natural magnets, specifically lodestones. And because of that, he made a key discovery. He discovered that magnets always have two poles, and these are now what we call the North Pole and the South Pole. And if you remember from our previous discussion, he also discovered that no matter how small you cut a magnet, it will always have two poles. We can never isolate just one pole. We can never get a monopole magnet. You will always get both. Also, when freely suspended or when you allow a magnet to rotate freely, no, kapag nakahang lang siya sa hangin, nakatali, a magnet's north pole points to Earth's geographic north, and at the same time, the south pole points to Earth's geographic south. Kasi nga, all magnets naturally aligns with the Earth's magnetic field. Then not long after, in the 13th century, we have Peter Peregrinus of France, who made another important observation or discovery. He noticed that magnetism is concentrated at the poles rather than spread evenly throughout the magnet. That is why, if we will try to use a magnet now to attract something, to attract, for example, a metal or another magnet, doon siya na-attract sa poles. Kasi doon mas malakas yung ating magnetic force or yung ating magnetism. Kasi nga doon siya concentrated, hindi kalat-kalat. No? It is denser and it is more concentrated at the ends or at the poles. Also, he discovered the basic rule of interaction between poles of magnets. And that is, like poles repel, unlike poles attract. Yun na yun. And this behavior is now known as the law of magnetic poles. It was later confirmed by William Gilbert in the 1600s, who also showed that Earth is a giant magnet. So itong ating law of magnetic poles is like north repels north, south repels south, and north attracts south or vice versa. And then next, scientists started asking how strong is the magnetic force between two poles. So in 1750, we have John Michel, who proposed that force between magnetic poles varies inversely with the square of the distance between them. Ibig sabihin, kapag meron ka daw dalawang magnet, dalawang pole ng magnet, no? So the force of that varies inversely with the distance between them. Meaning, magnetic force gets weaker as the poles move farther apart. And magiging mas malakas yung ating magnetic force pag mas malapit yung ating dalawang poles. Pwedeng attractive force kung they are unlike poles. If you have north here and south pole here, so mas malakas yung attractive force nila kapag mas malapit, mas mahina kapag mas malayo. And at the same time, if you have two like poles, for example, you have a south and a south, no? So meron tayong repulsive force. So pag mas malapit sila sa isa't isa, malakas yung repulsive force. So ma-observe mo yun na talagang gagalaw, tuturit yung ating magnet. At the same time, kapag nalayo natin yung dalawang south na yan, mas mahina na yung repulsive force. Hindi sila magdidikit, pero at the same time, hindi mo na masyadong ma-observe yung paglayo or yung pagturit ng magnet. That is because of the inverse relationship of the force and the distance. Next, in 1785, we have Charles de Coulomb, who showed that this force is similar to the one between electric charges, which is directly proportional to the product of the pole strengths and inversely proportional to the square of the distance. So dito nagdagdag siya, no? Nagdagdag siya na meron tayong product of the pole strengths and distance. Para mas maintindihan, this is the formula that Charles de Coulomb proposed. So for him, we have force is equal to K, which is a constant, and then product of two poles, m sub 1 times m sub 2 over the square of the distance. And yung constant natin is equal to 10 raised to negative 7 Newton over ampere squared. Okay, again, this is our formula. Anong ibig daw sabihin ng relationship between force, magnetic poles, and distance? So our force has a direct relationship with the strength of the two poles and inverse relationship with the square of the distance. So ibig sabihin, pag mas mataas, pag tinaasan natin yung strength of poles, mas tataas yung force. Pero kapag tinaasan natin yung distance between two poles, hihina yung force. Direct relationship with the magnetic poles strength and then inverse relationship with the distance. Okay. To better understand the formula, let us try to apply it with this example. So we have here example number 1. Two magnets are separated by a distance of 10 centimeters with their S poles facing each other. If each pole has a strength of 2 am, what is the force between them and what kind of force is this? Wait, how to do that? Okay, so first, of course, we need to identify the given. So what are the given in this problem? We have here two magnets are separated by a distance of 10 centimeters. So we have a D. However, going back to our previous slide, sabi dito, distance, D is the distance in meters. Again, meters dapat yung units ng ating distance. So, since we have here cm, we need to convert it first, which is now D is equal to 0.1 meter. And then, what else do we know? With their S poles facing each other, and each pole has a strength of 2 am. Ano tong 2 am na to? That is your M. M sub 1 ba siya or M sub 2? Both. Kasi sabi dito, each pole has a strength of 2 am, meaning M sub 1 is equal to M sub 2, which are both equal to 2 am. Ampere meters. And then now, what is the force between them? So to answer this question, we now have to plug in these values in our formula, which is force is equal to K times M sub 1, M sub 2 over D squared. Our K, if you remember, is equal to 10 raised to negative 7 N over A squared. And then our magnetic pole strength is 2 am and 2 am. Then our D is 0.1 m squared. Now, if you will calculate this using your calculators, 10 raised to negative 7 times 2, which is 4, divided by 0.1 squared, you will get 4 times 10 raised to negative 5 newtons. Bakit newtons na lang yung natira? Since we have a force here, then automatically the unit involved is in Newton. And how did we arrive at Newton? If you will observe the units dito sa taas, so we have here N, and then over A squared. Then if we multiply AM to AM, we will get A squared M squared. So we can actually cancel the A squared. And then if we have M squared sa taas, meron kang M squared sa baba, makakancel out din yun. Ano yung naiwan? Newtons. So the answer is the force between the two S poles is 4 times 10 raised to negative 5 newtons. And then meron tayong second question, which is what kind of force is this? Attractive force ba siya or repulsive force? Okay, so since we have here two magnets, tapos S poles are facing each other, magkaharap yung S at S, meaning this is a repulsive force. So, yung repulsive force nila na yun, gaano daw yun kalakas? 4 times 10 raised to negative 5 newtons. No? Medyo mahina lang. Mahina lang talaga. Okay, let's proceed to our second example. Two magnetic poles with strengths 3 am and 4 am exert a force of 1.2 times 10 raised to negative 5 newtons on each other. What is the distance between them? So, baliktad lang yung question, no? We now have force, given as a force, and given din yung ating magnetic poles, strength of magnetic poles, and then ano yung hinahanap natin, the distance. So, first again, identify the given. We have 3 am, that will be our m sub 1. And then we have another m, which is 4 am, and a force of 1.2 times 10 raised to negative 5 newtons. What is the distance between them? So let us use the formula proposed by Coulomb, and that is F is equal to K times m sub 1, m sub 2 over d squared. So pwede namang i-plug in na natin kaagad yung values, or gusto nyong galawin na muna natin yung formula. So kapag pinaikot natin yan, simple lang naman. We just need to interchange lang natin. We just need to interchange the f and d, and then get the square root of the other side. So if we derive this formula, we will arrive at this format. So d is equal to the square root of k times m sub 1, m sub 2 over f. Yung k actually, pwede nyo nang isama yan kay k, ay dito kay m. Kahit hindi na siya nakahiwalay dyan, pwede nyo na siyang ilagay doon yung constant kasi multiplication pa rin naman siya. Okay, and then let us now plug in the values. We have k 10 raised to negative 7. And then the two poles, we have 3 am and 4 am. And what is the force? 1.2 times 10 raised to negative 5. And then use your calculators, we will get a distance of 0.1 meters squared, square root of 0.1 meters squared, or approximately equal to 0.316 meters. Okay. Actually, hindi natin alam kung this is a repulsive or attractive force since it was not mentioned which poles are facing each other. So, ang tinatanong lang dito is the distance. And we now have the distance which is equal to 0.316 meters. Okay. For this example, we have two poles are placed 20 centimeters apart and experience a force of 5 times 10 raised to negative 6 newtons. If one of the poles has a strength of 1 am, what is the strength of the other pole? So, meron na tayong distance, we have a force, and we have a pole strength, o isang magnetic pole strength. And then we are looking for the other pole. So, again, let us first identify the given. Asan yung mga annotation? Okay. Okay, so first, what are the given here? We know the distance, and it is 20 centimeters. But again, we need to convert it first to meters. So, 20 centimeters is equal to, ayaw magtanggal. 20 centimeters is equal to 0.2 meters. And then we have here a force. F is equal to 5 times 10 raised to negative 6 newtons. And we have m sub 1, which is 1 am. So we are looking for m sub 2. Going back to our formula, it's your choice na kung i-memorize nyo ba yung naka-derive na formula, or if your strength is your algebra skills, pwedeng itong isa lang and then kayo na bahalang mag-derive on your own sa exam or sa quiz. But in this example, binigay ko na yung formula to find the second magnetic pole strength. And that is equal to m sub 2, which is equal to fd squared over km sub 1. Now let us plug in the values. Our force is 5 times 10 raised to negative 5 times 10 raised to negative 6. And then d is equal to 0.2 m squared. And then our k is 10 raised to negative 7. And then m sub 1 is equal to 1 am. So again, just use your calculators. Tapos, ang lalabas dyan is 2 times 10 raised to negative 7 over 10 raised to negative 7, or that is equivalent to 2 am. Our magnetic pole strength is 2 am. So we have two poles. The other one is 1 am. The other pole is 2 am. And this one is the last example. Two magnets have pole strengths of 2.5 am and 3.5 am, placed 0.05 m apart. What is the force between them? And is it attractive or repulsive if one N and the other is S? So it's just like the first example that we have earlier. We have here 2M. M sub 1 is 2.5. M sub 2 is 3.5. And then the distance is already given 0.05. We are computing for the force. So that is the default formula. Force is equal to K times M sub 1, M sub 2 over D squared. Plug in the values. Constant is 10 raised to negative 7. M sub 1 is 2.5. M sub 2 is 3.5. And the distance is 0.05. Use your calculators and we will get 3.5 times 10 raised to negative 4 newtons. So that is the force between the two poles. And the other question, is it attractive or repulsive if one is N and the other is S? So of course, this is an example of attractive force. Unlike poles attract. So we have an attractive force of 3.5 times 10 raised to negative 4 newtons. Moving on to our next topic, which is about the magnetic field. A magnetic field, or also known as the B field, is a physical field that describes magnetic influence on moving electric charges, electric currents, and magnetic materials. O kaya, isipin nyo lang na it is a region where a magnet can exert a force on magnetic materials. It's like, if I am a magnet, meron akong certain field dito sa paligid ko, meron akong aura nakapaligid sa akin. And inside that field, inside that area, I can attract or repel certain materials. Outside that area, of course, wala na akong impact doon sa mga materials na yun. So that is the magnetic field. And magnetic field lines represent two, the strength and the direction of the magnetic field. So strength, in terms of the strength of the magnetic field, if you see the field lines as close with each other, if they are closer together, then the field is stronger. And at the same time, if the field lines are further apart, then the field is weaker. No, closer lines, stronger field. Farther lines, weaker field. Pag mas dikit-dikit sila, mas malakas yung ating magnetic field intensity. And kapag mas layo-layo, mas mahina yung ating magnetic field intensity. And field lines always have an arrow indicating the direction of the field line or of the magnetic field. Or kung hindi nyo man makita yung arrow, you should know that the field line always go from north to south. Always go from north to south. Okay, so to illustrate, so we have here an example of magnetic field lines. Sabi natin kanina, kapag mas dikit-dikit, no? Pag mas dikit-dikit yung ating lines, for example, here sa poles, mas dikit-dikit yung lines, meaning mas malakas yung ating magnetic field. Mas intense dito yung ating magnetic field. And as the distance increases from the magnet, hihina na yung ating magnetic field. Yan. Strongest at the pole, and then pahina ng pahina habang lumalayo sa magnet. Kasi kung makikita ninyo, mas hiwa-hiwalay na yung lines. Okay? Clear ko lang. Next, how about the direction? Wala tayong arrows dito, pero sabi nga natin, magnetic field lines always go from north to south. baka ma-confuse kayo, no? Kasi nakikita nyo pumapasok dito sa south, lumalabas sa north. Usually, ganun. Tapos sasabihin nyo, so south to north yung direction, but no. Actually, it starts from north papuntang south. North papuntang south. Yan. Then, north to south, north to south. Kaya nyo siya nakikita ang pumapasok dito sa south. Kasi that is from north papuntang south. Okay? Playable tong video na to, I think. Wait. Yan. Ganyan. That is the direction of the magnetic field lines. Okay? Now, if we have one bar magnet, so ganun lang din yung itsura niya sa kanina, sa magnetic field lines natin. Again, strongest at the poles, tapos pahina ng pahina habang lumalayo sa magnet. Now, what if we have two bar magnets? So if we have two bar magnets, they can now either attract or repel each other at mag-iiba na yung itsura ng ating magnetic field. So for example, if we have two attracting bar magnets, if we place two magnets so that the north and the south poles are facing each other, yung isa north, yung isa south, then you will observe that the field lines will connect cleanly between them. This one. Nag-connect yung field lines ng isang magnet to the other magnet if they have attractive force. Pag pinagtapat natin yung unlike poles, no, magko-connect yung ating magnetic field, and so we can create a uniform magnetic field between them. It will attract. They will attract each other because of that uniform magnetic field. Yan. The same time, ganyan din dito, binaligtad lang natin. What if yung south naman, tapos yung north, mag-a-attract pa din. And if you will observe, ganun pa rin yung direction ng ating magnetic field lines from north to south. North to south. Na-attract niya. Okay? Now, what if we flip one magnet so that two norths are now facing each other, o kaya two souths are facing each other? So as you can observe, they will push away from each other. Nagkakaroon tayong tinatawag natin na dead zone dito sa gitna. Dead zone because we have no field, magnetic field lines in this part. Ayaw nilang mag-connect. Ayaw nilang mag-connect. Ayaw nilang mag-overlap. And that is why they repel each other. Again, if we have two repelling bar magnets, we have a dead zone in this spot, and this is space, because the magnetic field lines do not want to connect with each other. Ayaw nila. Okay? Yan. Two norths or two souths, pareho lang yung mangyayari. They will repel each other. They will not overlap. They will cancel each other out. Okay? Now, in mathematical view, we can define magnetic field in two ways. So first one, magnetic field is the region where a moving electric charge experience a force. Ibig sabihin, if a charged particle moves through a certain magnetic field, no, merong isang charged particle na pumasok dun sa magnetic field na yun, it will feel a force. Meron siyang magnetic force na mararamdaman only if it's moving. So kapag stationary yung charged particle na dumaan, stationary yung particle na binaba natin, for example, pinasok natin dun sa magnetic field, walang mangyayari. So, kailangan it's moving electric charge. And this is the formula for the first definition, wherein B is the magnetic field intensity, measured in Tesla or T. F is the magnetic force in newtons. Q is the electric charge in coulombs. V is the velocity, and theta is the angle between the velocity vector and the magnetic field vector B. Medyo madami siya na, pero iisa-isahin na lang natin siyang hahanapin later sa problem. Again, in this first definition, a magnetic field only exerts a force on a moving charged particle, and also the direction of the force is always perpendicular to both the velocity of the particle and the direction of the magnetic field. Diyan na daw pumapasok yung tinatawag nilang right-hand rule. Madami silang variation of right-hand rule, pero according dito sa ating illustration, ginagamit niya yung palm. Kita niyo ba yung palm? Ayan, this is my palm. This is my right hand. So, try niyo na lang din gamitin yung right hand niyo. So, for example, if this is the force, yung force natin, ganyan siya. It's black, hindi nakikita. Ayan. Ngayon yung force nyo. This is perpendicular to our magnetic field B. Andito si B. And then, andito si velocity. So, perpendicular si force kay B at velocity. I hope nakikita ninyo. So, andito daw si force, yung ballpen na nakapatong sa aking palm. And then, B, or the magnetic field intensity, the direction of the magnetic field intensity is towards my middle finger. And then, the velocity is towards my thumb. That is perpendicular. But anyways, simplihan lang naman natin ang example natin dito sa first definition. So, we have here an electron of Q equals 1.6 times 10 raised to negative 19 is moving at 2 times 10 raised to 6 meter per second at right angle. Takpan. At right angles to a magnetic field. If it experiences a force of 3.2 times 10 raised to negative 13 newtons, what is the strength of the magnetic field? As you can see here, it was stated that it's moving. No, it is moving. Therefore, meron siyang mararamdaman na force. Kasi nga naman, kung hindi siya moving, kung stationary siya, magzi-zero yung velocity natin. At kung babalik tayo sa formula natin kanina, if V is 0, then we will get an undefined equation. Tama ba? Pag nagka-zero itong baba, undefined na yan. So, kailangan gumagalaw. Kailangan may velocity yung ating electric charge or yung ating particle. Okay, so now let's identify the given. First, we have a force of 3.2 times 10 raised to negative 13 newtons. Then we also have a Q, that is the electric charge in coulombs, 1.6 times 10 raised to negative 19. Velocity is 2 times 10 raised to 6. And then, sabi, right angles. Right angles meaning that is 90 degrees. Okay, now let us plug in the values in our formula earlier. So B is equal to F over QV sine theta. What is our F? We know that that is 3.2 times 10 is negative 13. Our Q is this one. Our V is this one. And then sine theta or sine 90 degrees is 1. Okay, then use your calculators and you will get B, or the magnetic field, is equal to 1 Tesla. Again, the unit for magnetic field is Tesla. So, ganun lang. You just need to identify the given. Dito, yung mga given, and then plug in sa ating formula. Necessary na that is moving, it has a velocity so that hindi magiging undefined yung ating equation. Okay. Then we have the second definition for the magnetic field. In this definition, the magnetic field now is the amount of magnetic flux per unit area perpendicular to the field. So in this definition, we are not thinking about the force. Di na natin iniisip yung force na yon, kung ano mang force yon. Ang gusto lang dito sa second definition, ang gusto lang hanapin dito sa second definition is gaano ba kadaming magnetic field lines ang dumaan sa isang certain area. Now, so we have this formula, B is equal to magnetic flux yung symbol na yan, in Webers or WB. and then over area. So, mas simple yung formula natin for the second definition. B is equal to magnetic flux over area. Again, when we say magnetic flux, yung flux na yun, it's just like how many magnetic field lines pass through an area. So, maiisip ka agad natin, we can conclude na mas mataas yung intensity at the poles kasi doon madaming magnetic field lines na dumadaan compared pag doon na sa tuktok ng magnet kasi konti na lang yung magnetic field lines doon. So that is the meaning of the second definition. So for example, we have a magnetic flux of 2 Webers passes through a surface of 0.5 meters squared. What is the magnetic field strength? So very simple lang siya. Identify the given. Magnetic flux is equal to 2 Webers. And then distance, area rather, is equal to 0.5 meters squared. Plug in. 2 divided by 0.5 is equal to 4 Tesla. Ayan. Okay, so now let us try to recall what we have discussed for the 2 lessons. First, for the law of magnetic poles, which of the following statements is true about magnetic poles? A magnet can have only a north pole. B, like poles attract each other. C, magnetic poles always occur in pairs. And D, a magnet can have multiple north and south poles randomly. Which is true among these statements? Okay. So of course, we know that the correct answer is letter C. They always occur in pairs. That is according to our theory before na we cannot isolate a single pole. So always occur in pairs. Second question, what does Coulomb's law tells us about magnetic force? What does Coulomb's law tell us about magnetic force? A, it depends only on pole direction. B, it is constant for all magnets. C, it increases with the square of the distance. D, it decreases with the square of the distance. Okay, so isa-isahin natin. Letter A, it depends only on pole direction, only on pole direction. Of course, that is incorrect. Kasi nakadepend siya sa strength and distance. Strength sa taas, tapos distance sa ibaba. Letter B, it is constant for all magnets. That is incorrect. Force varies. Letter C, it increases with the square of the distance. It increases with the square of the distance. That is incorrect because the force has an inverse relationship with the square of distance. So it should decrease with the square of distance. Ibig sabihin, habang tumataas yung distance natin, bumababa yung magnetic field. Again, habang tumataas yung distance, bumababa yung magnetic force. Now, for magnetic fields, which direction do magnetic field lines always go? South to north, center of the magnet outward, north to south, or in random loops? This one is an easy question. We should not forget about this one. The direction is from north to south. Always from north to south. Do not be confused. Kapag inside the magnet, mukha siyang south to north, but technically that is from north to south. And finally, what does the spacing of magnetic field lines indicate? A, color of the magnet, temperature of the field, strength of the magnetic field, or the size of the magnet. Okay, very irrelevant yung ibang options. So the spacing of magnetic field lines indicate the strength of the magnetic field. It is related to our second definition kanina, which is yung magnetic flux. No? Pag mas madami yung field lines, pag mas dikit-dikit yung field lines, ibig sabihin madaming field lines ang dumadaan sa isang certain area, mataas yung flux doon, mataas yung intensity. Okay? Mas spaced apart yung ating mga field lines, meaning mas mahina yung ating magnetic field. Okay, that's it. See you in our next video. Hello class, let us proceed to our next topic in electromagnetism, which is the magnetic effect on current. So in this topic, we will answer how electricity can create magnetism. So these are the key concepts about that lesson. It says here that when a current flows through a conducting wire, a magnetic field is produced around the wire. So whenever we have a conducting wire daw is any wire that has a current flowing through it. Kahit ordinary wire lang yan, basta may current na nagfo-flow, we can call it as a conducting wire. And whenever we have a current doon sa conducting wire na yon, we will have a magnetic field around that wire. And then it also says here that the magnetic field is made up of concentric circles in a plane perpendicular to the wire. When you say concentric circles, those are several circles sharing the same center. So makikita niyo yun mamaya sa illustration na meron tayong several circles surrounding the wire and perpendicular daw siya doon sa may wire. Ayan. And also, those circles tells us about the strength, excuse me, about the strength of the magnetic field. Parang ganun lang din kanina sa may flux natin. Yan, dun sa may lesson natin about flux. So, yung circle na closer to the wire, doon mas malakas yung ating magnetic field. And then, as the distance increases from the wire, mas magiging layo-layo yung ating circles, mas magiging layo-layo yung lines na makikita ninyo, ibig sabihin mas mahina din yung magiging magnetic field. Okay? So this is the illustration. Yaang line na nakatayo, that is your wire, conducting wire. And what is the direction of the current? Upwards. Upwards. And then this is your magnetic field. Sabi natin kanina, it is made up of concentric circles, meaning we have several circles sharing the same center. Saan daw dyan yung pinakamalakas ang magnetic field intensity dito sa malapit sa ating wire. Then habang lumalayo yung circles natin, for example, may circles pa dito, mahina na yung magnetic field intensity doon. And also, sabi din kanina, it should be perpendicular to our current or to our wire. No, so, perpendicular yan. Okay. And to understand better about the direction of the current and the magnetic field, we will use this right-hand thumb rule. So this one is different from the previous lesson kasi yung una, right hand itself, wherein we only used our palm to know the direction. However, in this lesson, we will use our thumb, ball pen. Ayan. So for example, this is the wire. This is the wire. So what is the direction of the current? Lagay nyo lang yung inyong thumb. Ganyan. Okay. So nasa nakaturo yung thumb, doon yung current natin, towards upwards. And then the other fingers, they will tell us the direction of the magnetic field around this wire. Nakuha ba yung direction? Again, kung ganito yung pinapakita ko, meaning the direction is upwards. And then the other fingers, they will tell you about the direction of the field, the magnetic field lines. So, kung ang ating current is upwards, what will be the direction of our magnetic field lines? This is counterclockwise, right? And then, kung itataob ko yung aking current, baligtad, pababa naman siya this time. Ano yung direction ng ating magnetic field lines? Naging clockwise. Okay? So, kung ano man yung maging orientation niya, sundin nyo lang yung right hand thumb rule. Basta this is the current, your thumb, and then this is the direction of your magnetic field lines, your other fingers. Okay? And then it says here that if we want to increase the current through the wire, mag-i-increase din yung ating magnetic field intensity. Anong nangyari? So, for example, this first illustration, ito yung default, no? And then, nilakasan natin yung amount of current that is flowing through that wire. Anong nangyari? Nagdikit-dikit yung ating magnetic field lines. Nagdikit-dikit sila, meaning mas lumakas yung ating magnetic field intensity. So if we want to increase the magnetic field intensity, we need to increase the amount of the current. Okay? Changing the current direction. Ito na yung ginawa natin kanina dun sa right-hand thumb rule natin. Bagu-baguhin man natin yung orientation or yung direction of the current, as long as you know your right-hand thumb rule, hindi ka na mahihirapan. No? The magnetic field line is always perpendicular to the wire, and then paano yung kanyang direction? If upwards yung current, counterclockwise yung ating magnetic field. If downwards, magiging clockwise. Paano naman kapag, ano ba tong direction na to? Left. To the left yung ating current, what will be the direction of the magnetic field lines? From north to south. North to south. Ganun. Yung ikot niya. Pag ganito naman, paano ba? Basta ganyan siya. Nalilito ako yun. Basta bago-baguhin lang natin yung ating orientation and just follow your right-hand thumb rule. Okay? Ayan. Mas madaling makita dito na naging clockwise and then counterclockwise. This one is counterclockwise. This one is counterclockwise. That's it. And then let's start with your electromagnet. Okay, so point lang ng ating previous lesson is whenever you have a current flowing through a wire, you will always have a magnetic field. No, yun yung napatunayan nga ni Hans Oersted, accidentally doon sa kanyang science experiment ng estudyante ba siya. So yung mga nakikita ninyong wire sa bahay ninyo na meron tayong mga flowing current, meron dyan automatically like magnetic field. Okay. So now let's proceed to electromagnet. Ano ba tong electromagnet na ito? So what you see here in this photo is a coil of wire wrapped around an iron core. So meron tayong iron core dito sa gitna. That is the iron core. And then we have a coil of wires. So when electric current flows through the coil, it generates a magnetic field, and the iron core helps concentrate and strengthen that field. So ito yung example natin ng electromagnet. We were able to create a magnet because of electricity. Okay, sabi dito, the biggest advantage of having electromagnet is that it is temporary, meaning it can be switched on and off. So controllable siya, unlike our permanent magnets na laging activated yung magnetic field. Dito kasi sa mga electromagnets, they can be controlled, they can be switched on and off. Kapag pinatay natin yung pinanggagalingan ng electricity, then mawawala din yung ating magnetic field. Pag in-on natin yon, then magkakaroon tayo ng magnetic field. Okay? And then, yeah, sabi dyan, when the current is switched off, there will be no magnetic field produced around the electromagnet. Also, changing the direction of the current also changes the direction of the magnetic field produced by the iron. So, parang yung kanina, applicable siya sa mga electromagnets natin. If you change the direction of the current, you will also change the direction of the magnetic field. Now, we have several factors affecting the strength of the magnetic field of our electromagnets. First one, strength of magnetic field produced around a solenoid can be increased by solenoid. Nabanggit dito si solenoid, pero mamaya papakita natin si solenoid. No? Actually, yung image kanina is already a solenoid. So, what are the factors? Instead of solenoid, maybe let's use the general term electromagnet. Okay. So increasing the size of the current which is flowing through the wire. Another, increasing the number of coils in a given length of wire. Those are the two factors, no? Una, increase natin yung size of the current. Pag tinaasan natin yung amount of current, lalakas din yung ating magnetic field strength. So they are directly proportional. Another one, kung ayaw mong lakasan yung current, pwede naman na damihan natin yung coils. For example, 5 loop lang nung una. If you want to increase the magnetic field strength, dagdagan natin. Gawin natin 10 loops of wires. So lalakas din yung magnetic field doon. Another, maintaining the number of turns and reducing the length of wire. Maintaining the number of turns daw. It's like yung distances, ano ba? Yung distances natin ng pagbalot ng coil doon sa ating iron core ay dapat the same, no? Mas malakas yung magiging magnetic field na mapoproduce natin if we have a uniform distance. For example, limang same distance dito sa ang nakabalot doon sa ating iron core. And then adding an iron core through the center of the coils. Adding an iron core, sabi natin kanina may iron core na. Technically kasi class, we can use any kind of core. If you want to create an electromagnet, pwede kayong gumamit ng kahit na anong core. Kunyari, plastic lang. Yung core na gagamitin ko, kumuha ko ng plastic, balutan ko ng wire, ng conducting wire, makaka-create pa rin ako ng electromagnet. However, kung gusto natin na mas malakas yung mabubuo natin, yung mapoproduce natin magnetic field, mas malakas yung gusto natin na electromagnet, then it is suggested for us to use an iron core. No? Mas malakas yung magiging magnet natin. Again, increasing the size of the current, tataasan nyo natin yung amount of the current, number of coils, maintaining the number of turns, and then adding an iron core. Next idea, the strength of electromagnet can be changed by increasing the current to increase the magnetic field, just the same, and then decreasing the current to decrease the magnetic field. So obviously, if you want to decrease the magnetic field, bawasan mo din yung amount of current. Kung gusto mong bawasan yung magnetic field intensity, bawasan mo yung number of coils, no? Babaligtarin lang natin. Okay, so this is the solenoid. Yun yung nabanggit na solenoid kanina. So solenoid pa rin naman. Ayan, solenoid yan. Whenever you have wires na pinaikot-ikot, ginawa nating parang spring yung itsura, solenoid yung tawag natin doon. So itong solenoid, they act as a magnet. If we turn the current on, yung charge natin, pag in-on natin yung kuryente natin, no? Mag-act siya as magnet, it will produce a north and south pole according to the direction of the current. Ayan, makakapag-produce siya ng sarili niyang north and south pole. Nag-a-act siya as a magnet. So, ganito yung direction niya. Baka naisip nyo kanina na yung direction ng ating magnetic field ay random places, pero hindi. Para pa rin siyang bar magnet yung naging orientation of our north and south pole. So, from north to south, north to south. Ganyan. Okay? The magnetic field inside the solenoid is strong and uniform. And the ends of the solenoid behave like the north and the south of a magnet. Kung babaligtarin natin yung direction of the current, mababaligtad din natin yung ating north and south pole. Okay? Itong solenoid kasi, it's just like a fancy word doon sa wire na we coiled it into a helix or parang ang spring. Then, whenever we run a current through it, the field around each loop adds up and you get a stronger overall field. So kaya mas mataas yung ating magnetic field kung dadagdagan natin ng coil kasi nag-a-add up yung mga magnetic field per coil. So kung 5 coils lang yung meron ka, 5 coils, 5 coils lang yung nag-a-add up. 5 coils lang yung nagpo-produce ng magnetic field. Okay? So kung dadagdagan natin yun, nag-a-add up lahat ng yun to create a stronger magnetic field. And also, this is a temporary magnet. Bakit temporary magnet? Kasi nag-i-induce lang tayo ng electricity, meaning temporary lang yung pagkakaroon niya ng magnetic field. Pag hinugot natin, wala na rin. Nadi-disappear na din siya. And ano pa ba? Yan. This is the guide for the direction of the current and the location of our poles. So if we have a clockwise current, ayan, we will see a south pole. And then for counterclockwise current, we will have north pole. Okay, so this is an example. This is an example of our solenoid or electromagnet. Nakita nyo na to before sa PPT natin, no? We have a nail, tapos binalutan siya ng wire, and that wire is connected sa battery. So this is a temporary magnet. No, it will act as a temporary magnet kung connected yung ating wires sa battery. Okay, basta meron tayong nagfo-flow na current doon sa mga wire na coiled, we have an electromagnet or a solenoid. Okay, that's it. So before we end this discussion, let us just summarize what we have discussed. An electromagnet, it is a controllable magnet made from current and coils. Controllable siya. We can switch it on and off. And then, its magnetic field can be turned on and off and even reversed. Paano natin nababaligtad yung kanyang magnetic field? By reversing the direction of the current as well. And then, we can boost its strength with more current, with more coils, and with an iron core. Possible ba makagawa ng electromagnet without an iron core? Yes. As long as meron kang niloop na wire, meron ka ng electromagnet. Pero kung gusto mo nga palakasin, we can add an iron core. Okay? Anong nangyari? Okay. So now let us answer some questions. First one, what happens when current flows through a straight conducting wire? Again, what happens when current flows through a straight conducting wire? Letter A, nothing happens. B, heat is produced but no magnetic field. C, the wire becomes permanently magnetized. And or D, a magnetic field is produced around the wire. Okay? So obviously, the answer is letter D. A magnetic field is produced around the wire. Whenever we have a current flowing through a conducting wire, meron tayo magnetic field. Ano yung direction ng magnetic field na yon? Perpendicular. Perpendicular to the direction of the wire or the current. Next, what happens to the magnetic field when the direction of current is reversed? Again, what happens to the magnetic field when the direction of the current is reversed? A, magnetic field becomes stronger. B, magnetic field disappears permanently. C, magnetic field reverses direction. Or D, nothing changes. Okay, so if we reverse the direction of the current, hindi mawawala yung magnetic field. Andyan pa rin siya. Hindi magbabago yung kanyang intensity. However, ano nang mangyayari? Yeah, it will also reverse its direction. The magnetic field will reverse its direction. Next, which of the following increases the strength of an electromagnet? Again, which of the following increases the strength of an electromagnet? A, using fewer coils. B, increasing the current. C, reducing the current. Or D, using a plastic core. Ayan, very easy lang. Letter B, increasing the current. Kasi nga, we want to increase the strength. So if we use fewer coils, hihina yung magnet. If we reduce the current, hihina yung magnet. If we use the plastic core, hihina din siya. Okay? And finally, what happens when the current is when the current in an electromagnet is switched off? What happens when the current in an electromagnet is switched off? A, magnetic field becomes stronger. B, magnetic field reverses. C, magnetic field disappears. Or D, iron core remains magnetized forever. Okay, so whenever we switch the current off, then the magnetic field automatically disappears. Kasi nga temporary magnet lang siya. Pag tinanggal natin yung source ng electricity ng current, then mawawala na rin yung kanyang magnetic field. Okay, so that's it. I hope you will prepare for your quiz and exam. I hope that you will watch this video and then I will give an activity regarding the past 4 lessons. Okay? From lesson 2 up to electromagnet. Bye-bye.